Introduction to System Analysis and Design by Maria Teresa Sebastian. In this presentation, I will able to discuss the system analysis and design overview, discuss the system's development life cycle phases and activities, and discuss the system's development life cycle methodologies. The methodologies of SAD. A SAD methodology can also be referred to as a systems development life cycle that includes the development process as well as the ongoing maintenance process. What is software development life cycle? Is a conceptual model which includes policies and procedures for developing or altering systems throughout their life cycles. This is also the process which a software system being developed goes through. The system itself is intended to be the solution to a problem. As is the case with most solutions, implementation takes place through a process. For example, when a company wants to expand its warehousing capacity, they have the option of either buying, renting, or building a warehouse. Whichever option they pick, they'll have to go through a process of planning, surveying, and final acquisition. Some of the things to be considered will be warehouse size, distance from the current warehouse and offices, number of new staff required, etc. It is the same thing with software development. The software development life cycle is the process which guides you through the project from start to finish. SDLC activities are requirements, design, implementation, testing, deployment, operations, and maintenance. Systems development life cycle is a systematic approach which explicitly breaks down the work into phases that are required to implement either new or modified information system. The first phase of the SDLC is planning and feasibility, which obtain approval for project, initiate, assess feasibility, plan, schedule. In this stage, system analyst must define the problem and scope of existing system, overview the new system, and determine its objectives also. During this phase, threats, constraints, integration, and security of system are also considered. And lastly, the feasibility report for the entire project is created at the end of this phase. Analysis and specification is the second phase of SDLC. Requires to understand the business needs and processing needs, gather, analyze, and validate the information. Define the requirements and prototypes for new system, evaluate the alternatives and prioritize the requirements, examine the information needs of end user and enhances the system goal. A software requirement specification or SRS document, which specifies the software, hardware, functional, and network requirements of the system, is prepared at the end of this phase. The third phase of SDLC is the system design. In this phase, includes the design of application, network, databases, user interfaces, and system interfaces. Transform the SRS document into a logical structure, which contains detailed and complete set of specifications that can be implemented in a programming language. Create a contingency, training, maintenance, and operation plan. Review the proposed design. Ensure that the final design must meet the requirements stated in SRS document. Finally, prepare a design document which will be used during next phases. Implementation is the fourth phase of SDLC, which obtains to construct, test, train the user, install new system. Implementation is a process of ensuring that the information system is operational, allows the users to take over its operation for use and evaluation. It involves training the users to handle the system and plan for a smooth conversion. Implementation is also combine all the modules together into training environment that detects errors and defect. A test report which contains errors is prepared through test plan that includes test related tasks such as test case generation, testing criteria, and resource allocation for testing, and integrate the information system into its environment and install the new system. Maintenance is the last part of SDLC. Include all the activities such as phone support or physical on-site support for users that is required once the system is installing. Implement the changes that software might undergo over a period of time, or implement any new requirements after the software is deployed at the customer location. It also includes handling the residual errors and resolve any issues that may exist in the system even after the testing phase, and maintenance and support may be needed for a longer time for large systems and for a short time for smaller systems. The 7 basic software development life cycle methodologies: 1. Waterfall. 2. Spiral. 3. Prototype. 4. V-shape. 5. Iterative. 6. Incremental. And 7. Agile. Now let us discuss those methodologies. The waterfall is the classic SDLC methodology which has been used for many years. Being linear and sequential, it emphasizes on the need for a logical progression of the phases involved. One phase must be carried out to completion, then its output used as the input for the next. A short discussion on what happens at all stages will be in order. This model uses a sequential approach while working like a prototype. This way, it delivers a system that is not complete but is under constant review. The biggest differentiating aspect, though, is that it is focused on risk analysis. It is best suited for projects where risk management is critical. This model is mainly focused on providing an approximation of the final system at the initial stages. It is widely used when fixed requirements are not available. A prototype is built to show how the final product will look and work. With the prototype, there is no full functionality provided. The prototype is then subjected to tests by the customer to check if all the requirements are met. If not, more information is gathered. With the additional information, the prototype is updated and availed to the customer for further testing. It is only after the customer gives an approval that the production starts. Similar to the waterfall method, the V-shaped model is linear and sequential, though different. The difference is in the associated tests for every development stage. These are the tests which will be run after the coding phase to confirm that the requirements at each stage are met. It is also called the verification and validation model because every phase has a validation test attached to it. The left side of the V has the verification phases while the right side has the validation phases. At the bottom is the coding phase. The verification phases are used to check that all requirements have been factored into the system. The validation phases, on the other hand, confirm that the requirements have been met by the developed system. The iterative model begins development by building only a part of the software. Full specifications of requirements are usually not known. The small part of the system developed is reviewed to identify further requirements. Every successful iteration produces a software build upon which more features are implemented. This continues until the final system is achieved. This model focuses on building the whole system in small portions. It works quite similarly to the iterative model, but the difference is that this approach starts with the full knowledge of requirements. This determines the number of smaller portions of the system to be built. When these portions are finished, they are delivered to the customer as complete modules. It uses the classical waterfall approach, only that it does not build the whole system at once. This method is used to counter the limitations of those which cannot cater for a fast-changing environment. Projects which use the agile approach always have their requirements changing quickly. This approach is based on the iterative and incremental processes. It guarantees customer satisfaction through quick deliverable parts of the whole systems. The cycles through which the system is delivered are called sprints. The agile approach focuses on delivering a working software while ensuring customer collaboration. Thank you so much for watching.